Welcome to the deep dive. Today we're exploring a truly fascinating leap in artificial intelligence. We're talking about robots moving beyond those, controlled factory settings and heading right into the messy, unpredictable real world, our homes, streets, disaster zones even. So the question is, how do you make AI smart enough and fast enough, really, to handle all that chaos? There's this hint of AI models running on device. Right on the robot. That sounds like a huge shift for robotics. Okay, let's unpack this.
Exactly. And our focus for this deep dive is specifically Google DeepMind's Gemini Robotics On-Device. We're going to explore how this advanced vision language action model, a VLA model, operates directly on the robot hardware. We'll look at its capabilities, which are pretty impressive, how it performs, and also, really importantly, the safety approach and how they're making it accessible to developers. It's all about understanding, this next generation of robots that could actually be helpful in our daily lives.
Okay, so let's jump right into that core idea, on-device. You mentioned Gemini Robotics On-Device is a state-of-the-art VLA model optimized for general-purpose manipulation. But what does it really mean for an AI to run on-device instead of, say, relying on the cloud? Why is that such a big deal, such a game changer for robots outside the factory?
Right. Running on device is absolutely fundamental for real-world robots. Two main reasons, really. First, you get incredibly low latency inference.
Okay, low latency, so quick decisions.
Exactly. Split-second reactions. Think catching something falling or handling something fragile very gently.
Yeah.
It needs to react now. And second, maybe just as crucial, it means the robot doesn't need a constant data connection.
So it can operate independently.
Precisely. Imagine a robot in a remote area. No Wi-Fi, or maybe a construction site where the network is spotty. That independence means robustness. It can keep working. That's just non-negotiable if you want reliability in the real world.
That makes perfect sense. No more worrying about a dropped connection when the robot's mid-task. So we get how it runs now, fast and independent. Let's talk about what this lets them do. DeepMind says Gemini Robotics brings Gemini 2.0's reasoning and world understanding into the physical world. Here's where it gets really interesting.
Yeah, this is where you see the leap. The capabilities really change the game from, say, single-task machines to something much more adaptable. First off, there's multimodality.
Multimodality. Okay.
It's not just seeing, it's understanding and responding to text, images, audio, video, and then reasoning about the physical space to actually do something.
So it takes in all these different types of information.
All right, what you say, what it sees, maybe sounds around it to decide its next action. Then there's generality. This is huge.
Generalizing, meaning it can handle new stuff.
Exactly. It can generalize to novel situations. It's not just repeating programmed moves. It can handle new objects it's never seen, understand diverse instructions, work in unfamiliar places, like packing a lunchbox. Even if it's a brand of juice it hasn't encountered, it figures it out. Or preparing a salad with unknown ingredients.
That's much more like how humans operate. Okay, what else?
Interactivity.
Yeah.
It understands everyday commands, adapts quickly if you change your mind or the environment shifts, and it can continue the task without needing constant step-by-step instructions. More natural collaboration.
Fluid interaction. Nice.
Then dexterity. This is where you see really fine motor control. Tackling complex tasks needing precise manipulation. We're talking things like folding origami.
Wow, origami.
Yeah, or unzipping bags, folding clothes, drawing a single card from a deck, carefully pouring dressing, even complex industrial tasks like belt assembly, high-precision stuff.
Okay, that level of dexterity is impressive.
And finally, multiple embodiments. The same AI model can work on different robot forms.
So one brain, different bodies.
Pretty much. Bi-arm robots like Aloha, or the Franca FR3, even humanoid robots like Aptronic's Apollo. It shows how generalist the underlying AI is.
That adaptability across different bodies and all those tasks, that really is a step change. So how does this on-device version perform? You mentioned low latency, but does running locally mean any trade-offs compared to, say, a bigger cloud model, especially for that generalization and adaptability you talked about?
That's the key question, right? The trade-offs. And the results are actually very encouraging. Gemini Robotics On-Device performs similarly to the flagship cloud-based Gemini Robotics model on generalization and following instructions.
While running entirely locally.
That itself is a major achievement. Flagship performance, no cloud needed for inference. And importantly, it significantly outperforms the previous best on-device models, especially on harder tasks, things outside its training data, complex multi-step instructions. We saw improvements across benchmarks for visual, semantic, and action generalization.
Okay, so it's powerful even running locally.
Yes. And here's something really key for developers. Rapid task adaptation. It can learn a brand new task from as few as 50 to 100 demonstrations.
50 to 100, that's not many.
Exactly. You don't need these massive data sets just to teach it one new thing. It makes fine-tuning for specific jobs much faster and, frankly, cheaper. Big advantage.
Yeah, that rapid learning sounds incredibly useful for people actually building things with these robots. Quick iteration. So speaking of the builders, how is DeepMind making this technology available? You mentioned developers. I think I saw something about an SDK.
That's right. They've released the Gemini Robotics SDK software development kit. It's designed to make it easy for developers to evaluate the on-device model, adapt it to their specific robots and tasks. You can even test things out safely first in the Mijoko physics simulator.
Ah, testing and simulation before going to real hardware. Smart.
Very smart. It's a standard practice, helps avoid breaking expensive robots. And this is a big deal. It's the first vision language action model Google DeepMind has actually made available for fine-tuning.
The first one? Okay, that opens doors.
It really does.
Yeah.
Right now, access is through a trusted tester program. They're already working with key partners, people like Aptronic, building humanoids, Agile Robots, Agility Robotics, Boston Dynamics, the big names in advanced robotics, and also Enchanted Tools. So it's getting into the hands of innovators already.
That's great to see, putting it out there, but with robots this capable interacting in our world, safety has to be absolutely top of mind. So how are they ensuring these incredibly capable machines are also safe and, beneficial?
Absolutely critical question. And DeepMind emphasizes a comprehensive, layered safety approach. It's not just an afterthought. Everything aligns with Google's broader AI principles. They look at both semantic safety, like the content, what the AI understands or says.
Right, preventing harmful outputs.
Exactly. And also physical safety, how the robot actually moves and interacts with the world. Practically, this involves using tools like the Live API for checking semantic safety and, crucially, interfacing these high-level AI models with low-level safety-critical controllers on the robot.
Low-level controllers, what do those do?
They handle the immediate physical actions, ensuring things like collision-free movement, controlling the force exerted, like making sure it doesn't grip too hard, basic physical safety nets. For developers using the SDK, DeepMind recommends using semantic safety benchmarks and doing red teaming.
Red teaming, trying to break it.
Essentially, yes. Actively trying to find vulnerabilities, make it fail in unexpected ways so you can fix those issues before it's deployed in the real world. They also have internal teams, like the Responsible Development and Innovation Team, or REDI. Their job is to analyze the potential impacts, advise on minimizing risks, and maximizing benefits. And that's overseen by their Responsibility and Safety Council, the RSC, for high-level ethical guidance.
So multiple layers of checks and balances.
Yes, and they specifically consider risks like mistakes or misalignment, the AI hallucinating or just getting things wrong, also bias and fairness issues, and of course, potential misuse, people trying to bypass safety features, what they call jailbreaking. They're thinking about these proactively.
It's reassuring to hear that level of thought going into the safety and ethical side from the start. Okay, let's zoom out for a final thought. What's the bigger picture here? The Google DeepMind mission that drives this kind of innovation?
Yeah, it really ties back directly to their core mission statement, which is to build AI responsibly to benefit humanity. They often talk about making AI helpful for everyone, making it more accessible, including through education for the next generation, and constantly working on AI safety, proactive security against new threats. These advancements in robotics, like Gemini Robotics On-Device, are seen as a direct way to bring that beneficial AI into our physical world, but doing it thoughtfully and safely.
Okay, so we've really dug deep into Google DeepMind's Gemini Robotics On-Device today. A significant step for sure. We've seen how running that advanced AI right on the robot, the low latency, the network independence really is a game changer. Its capabilities, the dexterity, understanding different inputs, adapting to new things, working on different robot bodies, it's impressive. It allows for complex tasks in the real world. And importantly, we covered the strong focus on safety and making these tools accessible for developers, building responsibly. This deep dive really highlights how we're moving closer to a future where intelligent robots can handle complex, real-world tasks much more reliably.
And that really leaves us with a fascinating thought, doesn't it? As AI models like this one let robots interact with our physical world with such dexterity and adaptability, well, what happens next? What completely new kinds of human-robot collaboration might emerge? Or even entirely new industries that we haven't even thought of yet? It prompts you to consider the really profound implications as AI becomes, more tangible, more integrated into our daily physical lives.